How much did we miss? 15 minutes almost. Okay. So what is this now? This is the equation of motion during free fall. Clear? That's it. That's it. We were anyway to do numericals. I think in the last class we anyway went slow because many of you were absent. So now we are on par. Okay. So let's do the numerical. Do you have the textbook? All of you? Each desk? Girls have no textbook. You have? Okay, good. Okay. Anyway, so I'll read the question so that you understand. So which book are you talking about? Volume? No, YouTube. NCERT book नहीं है? हाँ निकालो.
So acceleration, which is due to gravity, is considered as g.
G, yes. Acceleration as well as retardation. So during free fall motion, A becomes G. This is what it is. Okay, now example 10.2. It is 9.2 in your textbook maybe. This chapter is chapter number 9 in your textbook. In volume it will be 10 still. Okay. What is the chapter number in your textbook for this chapter? 9. So we are doing example 9.2. It reads like this. A car falls off a ledge and drops to the ground in 0.5 seconds. Okay, so ledge is like some hill top. Okay, let's say the car fell from here. Okay, it is going to fall. This is ground. Ground meaning earth. So this is the vertical distance. So what will be speed at the top? 0. So car fell off a ledge and drops to the ground in 5.5 seconds. So the time it takes to fall is t is equal to 0.5 seconds. It falls. Let g is equal to 10 meter per second square. So in this question, g is given as g is equal to 10 meter per second square. This is given. For simplifying the calculation, that is also mentioned why they are taking g as 10 to simplify the calculations. Okay. So it is clearly mentioned, so you take this. If it was not mentioned, then you would take by default 9.8. If it is not mentioned. Now you have to find 3 things. What do you have to find? First, you have to find what is the speed on striking the ground. So let us say the speed on striking the ground is v. So you have to find v is equal to what? Okay. Final speed with which it will hit the ground. Ground पे पहुंचने के बाद नहीं, उसके बाद तो 0 हो जाएगा. Just before it hits the ground. Okay. What is the average speed during 5 seconds? So you have to also find the average during 0.5 seconds. Why average? It is 0 here and it is maximum here. In between it is continuously changing. Okay, so speed is continuously changing. So what is the average speed? That's what you have to find. Next, how high is the ledge from the ground? So you have to also find the height equal to what? Okay, so let's see how to solve this question. Okay, so what is given? U T, okay, and G. So you have U T G. So you can find V using first equation, right? What do you have to find? V and U T and G. You know. So which relation relates all these 3? The first equation. So for first, since V is equal to U plus GT, U is 0, G is 10, and T is 0.5. So this is 5 meter per second. Okay. So the velocity with which the object will hit the ground is 5 meter per second. Second, you have to find the average velocity.
Is final minus initial upon total time taken. Average velocity.
How do you find average velocity?
Yeah.
Total displacement upon total time taken. So do we know the displacement?
No.
What is the displacement? H. But we don't
find
know.
H first.
No, but it is asked before. So is there any way to find the average velocity? There is a formula for average velocity when the acceleration is constant. V1 plus V2, initial velocity plus final velocity divided by 2. You just take the average of the velocities.
Okay.
That is only applicable when acceleration is constant. And in this case, G is constant. The acceleration due to gravity is always constant. Meaning, when you drop the object, it is constantly accelerating with this acceleration. Got it? So, since G is constant, okay, therefore V average is equal to U plus V by 2. You just take the mean of the velocities. Okay, initial and final. So what do you get now? So this will be 0 plus, what did we obtain? V 5 divided by 2. So this will be 2.5. Okay. So this is a special formula for average velocity only when the acceleration is constant. मोशन चैप्टर में जाके देखो, उसमें दिया हुआ है टेक्स्ट बुक में, तुम्हारे इसमें वॉल्यूम में भी होना चाहिए. ठीक है? How many of you remember this formula?
I remember it was my sister taught me the night before exam. This
So this is a special formula
only when
the acceleration is constant. Yes. And when the body is undergoing different accelerations, then you have to find total displacement upon total time. Third now, how will you calculate, is the attendance signed? Where is attendance? Pass it ahead. So, how do we find H now? What do we know? We know U, we know T, we know G and T square. So we can take this, right? So we have to find the total height of the cliff from where it fell. So equal to UT plus half GT square. So how much is this? U was 0, 1 by 2, G is 10, T is 0.5 square. So how much is this now? This is 2 5s are 10. 5 into 25 is 125. So it will be 1.25 meter. Okay? So this is example 9.2 from NCRT. So you should go home and revise it. Read the question and then see the solution. Okay. Then the next question. Shall we go to the next one? Everybody has finished writing?
Yes.
Okay, the next question is, will you read the next question? 9.3.
to me. An object is thrown vertically upwards and rises to a height of 10 meters. Calculate the velocity with which the object was thrown upwards and the time taken by the object to reach the highest point.
So both the examples are covered here. One, this was downward motion. Now the next question is upward motion. Okay, so let's write down the given data. This is example 9.3. An object is thrown vertically upward. So let me draw the diagram. It's thrown vertically upward. And velocity is not given. We don't know. Then it reaches the height of 10 meters. So when it reaches the full height, h is equal to 10 meters. This is given from the ground. This is ground. Okay. So obviously at top, what will happen is v will become 0. Isn't it? I explained you at the top height, its velocity should become 0. So only these things are given. Then what are you supposed to find? You are supposed to find two things. Find velocity with which the object was thrown, and second you have to find the time taken by the object to reach the highest point. What is the time? Okay. To reach highest point. Okay. In this case, is G given in the question?
No, then we'll take it 9.9.
Is G given in the question?
No.
No.
We'll take it as 9.9.
Then you will take it as 9.8. Now is it understood when to take 10, when to take 9.8?
Yes.
When not mentioned, you have to take G 9.8. And where is G acting? Towards earth, towards ground. And where is the body going? Up. So now what sign will you take for G? Minus, because it is now retarding motion. Okay. So you find U. How will you find U? You know H, you know U, and you know V. So you know
You know V, H and G.
V, H, and G. You know, and U you have to find. So what is the equation which relates all this?
First.
Last. First two involve time.
Oh, yes, sir.
Without time, it is only this equation. Got it? So we have to calculate U. V is known, G is known, H is known. Okay, very clear. So don't get confused. From the given data and the thing which you have to find out, which formula relates them? This one. Okay? So now, so first one solution. Since V square is equal to U square plus 2GH. Now what is U square at the top? We know it is 0. U square you have to find out plus 2. Now what will be G? You have to take minus 9.8. H is 10. So rearrange. So therefore U square will be equal to minus will become plus now. So 2 into 98. Okay, how much is this? 16, 196. U square is 196. So therefore U is equal to square root of 196. Is it 14? How much is 14? 14 into 14? Anybody remembers 14 square? Happy birthday to you. Do you remember birthdays of every friend?
No. I can't remember.
Now you-
that.
Even I don't remember, so it's okay. So 14 into 14, कर लो भाई. 16, 1,
5.
5, 4, 196.
Yeah.
That means answer is 14. ठीक है 14 into 14 196 तो रूट क्या हो जाएगा Okay, how high is the ledge from the ground? कैसे निकलेगा?
Height of the
अरे मैंने मिक्स कर दिया. Next question, sorry.
time.
Time. You have to find how much time does it take to reach the top. Okay. So now how will you find out? Where is time equation? This and this. You know V, you know U, you know G, you know T. T you have to find out. So by first equation, can you find out? You can find by second also. But second में T square calculation लंबा हो जाएगा. If you like doing more calculation, do it. So you should be wise in deciding about the formula, which will be more sensible. So this will involve less calculation, right? So second वाला कर लो यहाँ से. ठीक है. So it can be solved by using second also, but this will be less time consuming. So now what is V? 0. U we found 14.
14 plus
G is
9.8
minus 9.8
minus 9.8.
T. Okay. We take it this side, so it will be 9.8 T is equal to 14. So we just rearrange. Here also, this minus sign became plus because we took it that side and then we wrote it the other way, right? So by minus sign, this minus sign, where did it go? Some of you might ask. I've taken U on the other side. Okay. So that becomes minus and this will be minus. Minus cancelled. That. So how much is T then? Therefore, T is equal to 14 divided by 9.8. How much is this? 7 to the 14, 7 1 to 7, 7 4 0. 2 by 14 is 1 by 0.7. So this is 10 by 7. How much is that? 7 1 to 7, 1.4. ठीक है 7 1 to 7, then 30. 4 to 22, 20. 1.42 second you can say, or just 1.4 second. Easily answer.
So maybe turn off the fan.
Which one? This? Yeah. Is the AC on?
You turn off the lamp.
Acha. Okay.
Thank you.
My wife. She's taking the revenge. Okay. What do you mean by free fall? In text question.
Okay, yeah.
This
A
is free
body
fall.
is said to be in free fall if the object is falling due to the influence of Earth's gravity.
Only.
Yeah, only.
When it is free fall. Okay. So I'm now reading the text question, right? This will be in your volume also. What do you mean by acceleration due to gravity? Wait. Who would like to answer?
So what was the question again?
What do you mean by acceleration due to gravity?
This is the easiest answer.
Have you heard acceleration due to gravity? Yeah, she wants to answer. Come on, birthday gang. What's acceleration due to gravity? You relax. I'll ask you.
This is too easy.
The energy girl would answer. Too much energy. Arey, you all don't try also. Try na, right, wrong. Don't worry about whether you are saying right. Right? Huh? Don't worry. Let them laugh. Go ahead. I'm not asking you to read. I'm saying.
Of the body when it falls.
Yes. So the acceleration with
The
which
body when it falls under
Acceleration which is
gravitation.
the acceleration with which
Which is produced when a body is under 3.2 Earth's gravity.
exactly that's what it is.
Kind of correct.
Yeah, it is correct only. See, it's only the play of word, but you have to try it. Okay, just because you'll get it wrong, you don't try it. That's the biggest misery. Let it be wrong. Speak once in a while, Adlina. Adlina, right?
Adlin.
Adlin. Okay, chalo. So don't mind if I take wrong names. Okay. So what is acceleration due to gravity? Now what is happening? This body is falling freely, right? So when it falls freely, it will develop acceleration. It will develop. So whatever is the acceleration of the freely falling body is acceleration due to gravity.
Acceleration produced due to gravitation of a free falling body.
Yes. Okay. Everybody got it? Now you repeat it.
Free fall.
Free fall is the process. The acceleration
In a body.
developed
Okay.
in a freely is acceleration.
Earth's gravitation. That is an
Complicated.
important word. My teacher
Acceleration developed in a freely falling body. When you say freely falling body, it means it is under Earth's gravity.
That's exactly what I argued. If you don't write gravitation, I won't give you marks.
ठीक है चलो. So gravitation is the force. ठीक है. So add the word gravitation also. The gravitation is Earth's gravity. So add Earth because gravitation is a general force between any two objects in the universe.
Earth's gravity.
So you say Earth's gravity. Then it is absolutely no confusion. Clear? You repeat.
It is a force produced.
I am saying accelerations
Yeah.
of force.
Sorry. It is.
You will start visualizing. Don't think that you're writing an exam or sir has asked you, whole class is watching it. Get rid of that consciousness. You will feel the acceleration due to gravity of this body. So what happened? Put it in words.
It is.
This is freely falling body.
Falling body.
So acceleration produced or developed in a freely falling body due to Earth's gravity. Just say gravity. Gravity is also force. Due to Earth's gravity is called acceleration due to gravity. Okay? So don't hesitate to speak out. Okay, this is the opportunity, right? Okay. Next we'll discuss difference between mass and weight. Have you measured your weight?
Yeah.
How many kgs are you?
49.
It's your weight or mass?
Sir, kg is the unit of mass.
You said 49 kg, right?
Yeah.
Is it your weight or mass?
Mass.
Then what's your weight?
Double.
No, it's something Newton's, right?
Yeah.
Is it like 1400?
Okay, wait. I had written it down. Okay. You
490,
multiplied
490, 10. Simplest 10.
Multiplied by 9.8 to get the.
Or 10 to simply. So your weight is 10 times more than your mass. So this is a misrepresentation, right? So this has become like a fashion. This is adopted by society that we call our mass as weight. Just like every toothpaste is Colgate. Colgate किया क्या? Have you heard it? क्या कर रहे हैं close up या फिर दंत कांति anything? But what are you saying? Colgate किया क्या? Xerox लिया क्या?
Xerox is just a brand.
Xerox is brand, just like Colgate.
Just Google it. Google it.
Xerox किया क्या मतलब? What is the general word? Photocopy. What is the general? Brush किया क्या? That is general. Toothpaste किया क्या? वो भी general है. Colgate किया क्या? That got no meaning. You got it? So weight कितना है? 49 kg. Weight है 490 Newton. समझ आया? बट ये एक्सेप्टेड है सोसाइटी में। अभी किसी को पहले मम्मी वही बोलती थी हमारी कोलगेट कर गया
सर ऐसे भी लोगों सर्च इट ना बोलकर हमेशा गूगल इट बोलते हैं। You can just say search it, but people say Google it specifically.
हाँ, so that is for searching. Search is a general thing.
Search is a general thing. Google is specific.
But everybody
Correct.
Googles.
So in today's times, that is applicable.
Google isn't the only search engine.
There is Bing
Bing it.
and
That does not sound bingable.
There's ChatGPT.
ChatGPT is just another
It is
level.
an AI assistant.
Yes.
You can say use it to search queries.
It gives you more specific answer. Search gives you
Yeah, but
very generic
when
answer.
people specifically say Google it.
Yeah, you're right. So just like toothpaste brush करने की बजाय क्या बोल दिया? Colgate कर दिया. वैसे Google. ठीक है? For search specific. So what is mass? What is weight? Are they the same thing?
No.
They are different. ठीक है? So let's understand. Let's mention the differences. So first thing you should understand is mass is mass and weight is weight. These two words are just so amused. What's it? What have you found? Thank God I'm not 10 times my weight. Huh? I'm only 49. Imagine 10 times bloated, full room full. Okay. Mass and weight. So first thing is, it is the measure of inertia. Go. It is the measure of inertia of a body. Okay. Now with this definition, which is in the volume and book, it doesn't make sense also. Okay. It's actually mass is the measure of the matter content of which the body is made.
Inertia is
opposition to its motion, right? But what is it? It is the measure of inertia of a body is given. You should also write also it is the measure of matter content in a body. Okay? Let's say water. So water is made up of water molecule. So 100 water molecule will have less mass than 1000 water molecule. Like that. So it's the matter content measure, that is mass. Okay? Its unit is kg. What about this? So what is weight then?
The gravitation applied, the force of gravitation applied on any object is weight.
Yes. It is the measure of
It is the measure of force of gravitation.
force exerted by Earth on any object.
Its measure is Newton.
Okay? So it is measured. Unit is?
Its unit is Newton.
Yes. Which unit is Newton?
Weight.
SI unit.
Oh.
So when you say full Newton, you write it in small case. Symbol is N. Then third, what is mass? It is a scalar quantity.
Don't tell me weight is a vector quantity.
Is it not?
How? kg.
Is it not force? Is weight not force?
Yeah, but how is it? Where is that?
It always acts towards the earth.
Okay, so the direction is
Obviously,
towards the earth.
it's always downwards. Right? Towards the center of earth. It is a force, right? So it has to be vector quantity.
So why do you say it's center of Earth instead of just like why specifically the center of Earth?
Why not center of Earth?
No, why can't we just say towards
So
Earth?
if
Why
I'm
can't we
standing
just say towards
here,
Earth?
if I'm standing here, so if I start digging perpendicular to the surface of Earth, where will I reach?
Center.
That's why.
But like, why can't we just say towards Earth? Why are we mentioning? the
What do you
center?
mean towards Earth?
You said towards.
center.
Where is
You said
towards?
you said
Where
towards
Earth is
the
an
center.
extended body, right? So where the force of gravitation works? Towards the center. When we defined universal law of gravitation.
Oh, I understand.
That's why. So every extended body, you always take its center as its address. Okay? Always. So where is our center?
Somebody balance me like this, I will
Yes.
find my center.
So you can be balanced somewhere around your navel area. On a sword, a magician will put you like this.
we have our volunteer.
Yeah. So it's somewhere in the stomach navel area. Okay.
Volunteer करेंगे ऐसा ऊपर करेंगे.
Have you seen that PC Sarkar magic show? Anybody seen? So when we were young, so we used to go to see magic show. Okay. So we used to put the person on a tip of the sword like this. Have you seen that?
Oh yeah, I've seen clips of
So if the person is balanced, that means he has been supported at its CG, center of gravity. Okay. Shall we go ahead? Next is
I have found the center.
it can be measured using beam balance. Mass is measured using beam balance. Have you seen beam balance?
So what?
What is that?
Beam balance. Have you seen it?
That one.
Taraju.
Oh yeah.
Taraju, you know?
So what?
No?
The thing that goes up and down.
Huh?
Okay.
You
What are
put
you talking
weight on
What do you call it?
Acha.
Is it not a balance? So one side you have slotted weights, and the other
I
side you
didn't know.
have.
I didn't know you called it a beam balance.
This is the beam. Beam is this. The
So I didn't know you called it a beam balance.
I'm sure everybody has seen this,
No,
right?
I know.
But nowadays it's a scarce commodity.
I didn't know.
I have that at my
But still,
grandma's
are they
place.
still using it? No. Now it's all electronic
They
beam.
use digital scale.
Everything is digital,
I've
right?
seen this. I think I've used it once.
Huh?
I've held this one. Like
You have to do it in your labs. Okay? School labs, it is there. In your school labs, it is still there. Okay? So you will get to see this. What about this? It is measured using spring balance.
Yes. What is spring balance?
I think
So I've used the spring balance in my lab as well. I've used the spring balance in my physics lab.
Spring balance, I guess, every household, when the newspaper collector comes to your house, okay, he brings Raddiwala, he brings spring balance, right? So spring balance,
Before going to airport, we measure the luggage with spring balance.
if you have spring balance at home, then
Yeah, but
Is it a scarf? Is it that scarf? Spring balance.
no, it's available
Yeah.
everywhere.
No.
Okay? So spring balance is used to
सबके पास होता है.
measure.
मेरे पास है
Oh my god.
मेरे पास है
Exactly.
So spring balance is calibrated in terms of Newton. Okay? And mass. One side mass, one side Newton. So mass will be just divided by 9.8. Okay? Whereas weighing balance, you will have slotted weights, combination of weights. Still, you will find some places, like fruit sellers. I have seen there is one fruit seller who keeps this weighing balance. It comes in two style. right? You
One is
have
supported from the bottom and one is supported from the top.
you have a pan here,
Yeah.
and you just keep the weights, and then this
The
gets
pan
balanced.
measure.
Yeah.
I've seen the second one more commonly.
Very common. It is still around. This is scarce because you have to hold it. It has to be
But
really.
the other one I've seen a lot. I've seen the other one is used.
What is the difference between these two beam balances? Here you have to hold it. This is already on the ground. So on the ground it is just like a seesaw. Here you don't have to hold. One side will keep the weight. Still you will get it with the fruit seller or
Yes,
vegetable.
I've seen it a lot. I've seen it a lot.
So this is not. This is also kind of beam balance, but the beam is somewhere hidden in between. Okay, and it is like pivoted balance. All right. One more last thing is mass of a body is constant throughout the universe. It doesn't change. Mass of a body is
Constant. Whereas
So, but
weight
weight is
changes.
determined by the gravity.
gravity
Weight
value, which changes from place to place. Mass of a body.
So like if I go to the moon, I'll weigh like much less.
Yeah, 1/6. You'll weigh 1/6 of what you're weighing on Earth.
I'm going.
So if you're 60 kg here, if you're 60 Newton here,
Then
over
I'll
here
weigh
you'll be 6 Newton.
6 Newton.
No,
So yeah, 6.
10 Newton.
Not
Yeah,
10.
divided by 6, it will be 10.
Mass of the body is always constant. See, all of you started enjoying physics now.
This chapter is kind of nice. This chapter is kind of nice.
All of you have smile on your faces, which is much different than the motion.
We will never study that
Motion
chapter.
had created a lot of pressure. Mass of the body is always constant.
And we did not even have a single physics question in our science paper.
Huh? Excuse me?
From
We
motion,
always
from
we
motion.
had optional, like there were 2 optional questions.
So it is as difficult to teacher as it is to student, okay? Because many concept of motion, like it's actually simple, but teachers also avoid due to graphs and all.
Our teacher suggests we spend up the chapter.
I know, because she has to do lot of work to make students understand.
Our teacher gave up halfway through both chapters, so we just know how.
It's not the teacher, it's also the student.
Yeah, our class is pretty annoying, let's be honest.
See, we draw energy from students' vibes, from your faces, okay? So if your faces, shoulders drop, then we also lose energy. Understand? So it all is action reaction, right? So if you're not receiving well, then giving doesn't make sense.
Third law.
So weight
Third law.
varies.
Second उसको याद नहीं हाँ भाई नहीं याद
Change this is change of acceleration due to gravity. So on Earth, where is weight maximum? Where is it maximum? On pole or on equator?
Equator.
The weight is maximum. All of you for equator?
No, it is equal.
All of you are wrong.
Yeah.
Yay.
All of you are wrong, right?
So I didn't say anything.
So why it is so?
Probably because everywhere it's equal gravitation.
So have you seen, let's say if you have a balloon full of water and you are rotating it, so what will happen? It will become oval.
So you'll be heaviest at the poles.
So he got the click. Okay. So if you have a perfectly sphered balloon full of water, now start rotating it. What will happen? It will be slightly pressed on the axis. So it will be bulged out near the equator, right? So the Earth shape becomes like this when it is revolving. Slightly bulges out around equator. This is the shape of Earth. So now what is the new distance from center? So pole becomes nearer to center of Earth and the equator becomes
Farther.
farther. So when the distance increases, what happens to force? If any object is kept on the radius of Earth, so the pole radius is less and the equator radius is greater. So where will be the weight more? So G becomes what? GME upon RE square, right? Isn't it? So where is G more? At pole or at equator?
At pole.
At pole, because RE is less at pole. Understood?
So I was thinking that on the magnet, the force of the magnetic attraction will be the greatest at the poles. That's
I'm
what I was thinking.
asking, wait, where did you bring magnet in?
So sir, weight is defined by gravity, right? Gravity and
Exactly.
gravity and magnetic force are very similar.
Stay focused. Gravitation is different. Magnet is also repulsive. Different nature of force.
Yes, but like gravitation
Yes,
force of
understood.
gravitation and magnetic force are very similar.
Why can't you stay on the topic?
So no,
It's a different area, I'm telling you, right? Magnetism is a different, you'll study in detail later on. It is only, this is a unique force, gravity. It is only attractive.
I thought it was like a type of same.
It's like just not giving up. What I'm saying is,
Yes, sir.
you understand what I'm
Yes, I
saying?
understand.
Okay. This is more due to the shortening of
Distance
distance
pole
between
and
the object which you are weighing and the center of Earth. ठीक है? ये picture भी आता है ऐसे, axis पे. ठीक है? So that is why. So this completes our discussion on mass and weight. Now the last topic is, I'll just quickly tell you, weight of. So weight of object on moon. ठीक है? Weight of object on moon is equal to 1/6 of weight of object on Earth. ठीक है? Always remember this. So what is weight of object on moon? Mass of the object. Does it change on moon?
No, sir.
No, the
No.
mass never changes.
So this is gravity on moon. This will be equal to 1/6 gravity on. So you get this relation. Gravity on moon is 1/6 the gravity on Earth. Make note of this. It will help you solve numerical. फटाफट लिख लो इसको. So today we'll end the class here. So with this we have completed half of the chapter. Now in the next class we'll begin learning about pressure.
Yeah, that's the bad part of the chapter.
Why do you conclude and judge so fast?
Sir, I realized that physics is just maths with more theory.
Like, how conclusive.
You're not fully wrong.
But sir does not fully agree either.
That's okay. That's with everybody. Nobody is perfect.
Okay, sir, no.
Everyone agrees to disagree.
Oh yeah.
Okay. Happy learning. Rest of the lectures. Bye bye.
Thank you, sir.
Thank you.
Julie.